9 o'clock. And so it's 9 o'clock, and we are going to get started with this evening's edition of the Global Math Department. Welcome, everyone. My name is Lee Natero, and I will be your host tonight. Tonight, we're going to be hearing from Daniel Kauffman about assessing for understanding. Before I introduce our speaker and turn the presentation over to him, I would like everyone to introduce themselves in the chat room, telling us what you teach, where you teach, and what your Twitter handle is if you have one. I know we definitely have people from Pennsylvania besides myself here. Phil, welcome. I know I saw someone from Mexico City, and we have people here tonight from New Zealand and Australia and Montana. So introduce yourselves in the chat window, and make sure if you have a Twitter handle that you put it there. Maybe you'll find some new friends to follow this evening. So tonight we're going to be hearing from Daniel Kauffman. Daniel is an instructional math coach, grades K through 12. He is currently in his 14th year of math education. For the first 9 years, he was a classroom teacher, teaching primarily AP statistics and algebra remediation. For the past 5 years, he has worked as an instructional coach and mathematics department chair. So right now, I will turn the presentation over to Daniel. Welcome.
Thank you, Lee, for that introduction. And just a couple more pieces on that. Yeah, I'm an instructional math coach for grades K through 12. My background is high school mathematics. I'm the math department chair for secondary mathematics at my district, grades 6 through 12. And I work at the Wilson School District, which is just outside of Reading, Pennsylvania, kind of southeastern Pennsylvania. And in this picture here, well, that's me on the left. And then my daughter Piper, she is 5 and she's in kindergarten. Lila is 7 and she's in 2nd grade. And my wife Quinn teaches 3rd grade. So right now she's well, hopefully the girls are already in bed. We'll see. But just know as I go through this presentation, I might reference when I'm teaching. I know I'm an instructional coach full time, but I do get the opportunity to teach lessons every now and then. For example, I'm teaching 5th grade tomorrow. I think it was on Friday, I taught kindergarten. So I do get the opportunity to teach, but just know that if I reference that, that's what I'm probably referring back to. All right, let's get going. So how did I get here? My teaching experience is in high school, and I've taught everything from algebra up to pre-calculus, and then I skipped calculus completely, and I've taught probability statistics and AP statistics. And in the 3 districts I've worked at, I've always taught statistics. It seems to be the class that teachers don't want to teach, or if somebody's willing to teach it, they will easily give it up. And I will say that teaching, and mainly AP statistics, if you ever get the chance to teach that class, please do it. It kind of changed the way that I operate. The focus of that class is not on crunching numbers. It's in interpreting data and drawing conclusions. And I think the hardest thing we ever do is take a square root in that class as far as math goes. But it kind of changed the way that I teach, and it made its way into the way I teach in algebra and the way I think about planning lessons. So if you ever get that opportunity, please take it up. I can't recommend it anymore. What we will do is later today, we will look at one of my original assessments. A lot of the stuff I'm going to show you today are things that I wish I did better when I was in the classroom. I think I could rename every presentation I do what I wish I had done when I was in the classroom. But we're going to look at one of my original Algebra 2 assessments later today. But to kind of get the ball rolling here, I want you guys to look at this problem, 2/3 plus 1/5. And please don't respond right away. Take like 15 seconds to just think about it. What skills does a kid need in order to add those 2 fractions together? So like what processes would they have to run through if they were going to use we'll call it the traditional algorithm to find the sum of those 2 fractions, right? So take a second to think about it and then start writing some stuff in the chat about, what a kid might need to do. Yeah, Lee, you said multiplication skills. Could you be more specific? Yeah, see, lowest common denominator, least common denominator. Converting to equivalent fractions. Understanding that you can't add them in their current form, not easily anyway. All right, so there are a lot of skills that a kid has to run through to add these together. And I listed a bunch of them here, the ones that I could think of. And first, they have to recognize that the denominators are not common, right? They have to know their multiples of 3, know their multiples of 5. They have to know the least common multiple. But if they don't, that's okay, as long as they reduce at the end, right? They have to know how to make equivalent fractions. They have to know how to add numerators. They have to reduce at the end if that's necessary. All these skills are prerequisites that go into this idea of adding fractions together. So, when we assess for understanding, a kid might know how to add fractions together, but they might not know their multiples of 3, say. And so sometimes that can muddy the waters as far as what we're assessing. Are we assessing their prerequisite skills, or are we assessing their ability to add fractions? All right, and that's kind of what we're going to get at today. All right. So now I want you to think about this process, right? And I'm going to call this like the following the recipe, or when I was a kid, I used to watch these music videos. I think they were like Winnie the Pooh, where you'd follow the bouncing ball and just sing the song, right? Kids that are very good at memorizing and sequencing do very well with these procedure skills, right? They can follow the recipe. They can make the brownies from the back of the box. And this isn't a challenge for them, all right? So I guess my question is, what would happen if we did this? Suppose kids did fairly well on 2/3 plus 1/5. Take a second in the chat there. What would happen if I asked them this question, 6/7 plus 7/8? I imagine that, if we ask 6/7 plus 7/8, the percentage of kids that would get this correct versus the first problem would probably be less. All right, so here we have this issue of we're assessing the same standard or the same skill of adding fractions, but with one problem, kids are more successful than they are with another problem. We all know that kids struggle with the multiplication of the 6, 7, and 8s. And so let's go ahead and just look at those standards and see the difference between maybe assessing for procedures and assessing for understanding. Oh, I see my students would want to cross cancel the 7s. I get that too. And my one colleague talked about using the bow tie method that he learned to add fractions together, which is just memorizing a sequence, right? It's not knowing what you're doing. You take the 8 times the 6, the 7 times the 7, and that's the bow tie method, I suppose. So let's look at these standards. On the left, we have these assessments for procedures. And I'm going to say this probably a couple times tonight. I don't want to give the impression that assessments for procedures are bad. If we look at the standard from 5th grade, it says add and subtract fractions with unlike denominators by replacing giving fractions with equivalent fractions, yada, yada, yada. So there is a piece to this. And, I'll talk to administrators and other people, and they'll say, oh, when am I ever going to use this? And, it doesn't matter. Like, you may not ever add fractions, but it is part of the standards. It's a 5th grade standard. So it is worth teaching and it's worth assessing. All right. What I would say then is, could we also assess for procedures and assess for understanding? And if you notice, there's actually 8 different pieces I have here. These are the standards for mathematical practice. These get kind of tricky. For maybe one reason is teachers don't know them as well as they should. but also they're not as concrete and not as defined as the assessments for procedures. When we do interviews for new math teachers, I'll ask, what do you want your kids to know at the end of the year? And without a doubt, they will start talking about, they want to know the curriculum, the standards, and of course, they'll start talking about assessments, these understanding pieces, these math standards, the practices. But if you ask, what does that look like in the classroom, I think they'd have a tough time explaining what exactly this understanding looks like. In other terms, assessing for procedures looks at your 40-minute, 40-day, and 40-week learning, where assessing for understanding looks at your 40-year learning. All right, so these are the big picture pieces, and I to be honest, I find it easy to gloss over them because when we look at our state assessments or our high stakes testing, a lot of it comes from this, and this almost isn't as important in the short term. All right. So one of the things we can look to do is to shift the depth of knowledge of our problems. If we want to incorporate this assessing for understanding, look to shift the depth of knowledge. So these are all depth of knowledge 1 type questions. All right, I would say that these are all kind of following the recipe on the back of the box. All right, solve, reduce, graph, plot, use a formula, recall, things like that. These are very similar to the first column if you look at the Bloom's taxonomy with the verbs. All right, a similar situation. I didn't need to show that graphic because I think it's redundant. But what we could do is look to shift the DOK. If we shift it to a DOK of 2 or 3, now look at the words we're using. Describe, explain, compare. And a lot of these, what happens if kids are going to use these DOK 2 and 3 is that they're going to have to start writing sentences or drawing pictures. All right, it's not just crunching numbers like they're used to. All right, and this is a big shift for kids. It's a big shift for teachers. All of a sudden, your math class becomes one where you're reading and writing mathematics, not just crunching numbers. All right. So what I'd like you to do is think back to that original problem. The original problem was to add 2/3 plus 1/5. All right, what would that look like if we shifted that into a DOK 2 or 3 problem? All right, so that's assessing for procedures, add those 2 fractions, 2/3 plus 1/5. How could we make that into an assessing for understanding? And I want to give you some time to think about this and put your thoughts in the chat. So how could we shift that problem to a DOK 2 or 3? Nice, Melissa. I'll also kind of go with the explain why. You can throw the verbiage I use a lot is convince me that 2/3 plus 1/5 isn't 3/8. Good, yeah. Drawing pictures. I'm going to talk about drawing pictures later in the presentation as well. And Cynthia, you said write a procedure. Do you mean kind of like how would you do this? Or describe how you would do this? Is that what you're trying to get at? Nice, John. Yep. We're going to talk about those concrete materials a little bit later too. Nice, Vicky. Oh, man. You guys are reading my mind here. This is good stuff. Yeah, just explain how to solve. We could completely eliminate the math. So Barbara wrote, explain how to solve this. We could completely eliminate the calculations of the math and just say, explain how you would do this and write it in like a narrative form with sentences and complete sentences and stuff like that. Yeah, a lot of good stuff. So some ideas I had floating around here. And keep in mind, anything that I show here is just kind of like my thinking, and it doesn't mean it's right, doesn't mean it's wrong. But a lot of these understanding questions can go in a lot of different directions. All right. Michelle, you're close to kind of what I'm about to show in a little bit. One idea I did have was just to describe how you would add 2/3 and 1/5. All right, which might be easier for some than actually going through the math. I know when I was taking geometry in high school, I struggled with proofs that were in like the T-chart that went one after the other because I didn't see that flow. It's kind of like just chunking it with these bits. And then in college, my professor had us write proofs in paragraph form, and I found that much easier to just write my thinking in that form. So I like this explain piece. A lot of these understanding pieces, by the way, the kids that are really, really playing the game of math, where the goal was to just get the right answer, get in, get out, with the least disruption, they don't like this shift because all of a sudden you're slowing them down, right? You're having them write sentences and things like that. And at first, I don't think they like it because you're not playing the game anymore, but it is worth doing. So this is what I came up with. And like I said before, this isn't right or wrong. The original problem was find the sum, and I changed it to, if we increase the 5, describe why the sum decreases, which would turn that definitely into something where they'd have to communicate some kind of understanding, either complete sentences. All right. I've removed kind of the calculations here. They might have to do a drawing if they wanted to. All right. What you don't want to do is to think that shifting the depth of knowledge just means making the problem harder. All right. So the original problem was 2/3 plus 1/5. Making it 6/7 plus 7/8 doesn't shift the DOK. It just makes it harder to do. That's it. Understanding isn't necessarily harder. It's just a deeper understanding. All right. Another place I'll see this too is in if you have kids solving 2 variable systems, teachers will then give them a 3 variable system, which is just, if anyone's done systems of equations with 3 variables, it's more of an organization piece than anything. All right. All right, so let's move on to, so that was the first idea. All right, increasing the depth of knowledge or shifting the depth of knowledge. And the same idea with the Bloom's taxonomy, just changing your verbs to the next column or the next tier, however you're looking at that. Another strategy we can look to do is to unpack compound questions. All right, and I see a lot of these, and I am guilty as anybody else for using these. All right, solve the inequality and graph on a number line. I've bundled 2 questions into this one question. All right, and as a teacher now, I've kind of made it a struggle for me to understand, like, what does a kid understand and not understand? And from a grading standpoint, this is a pain because we have all done this, where if a kid gets a minor mistake in the beginning, you then have to work out the entire problem through, and then you have to graph it. And then, how do you give them points for having it all correct with a little mistake? All right. So when we unpack compound questions, just make it into 2 questions. So what could those 2 questions look like? Go ahead and throw those in the chat. So if you were to unpack these 2 questions, what would it look like? Yeah, that first question would just be solve the inequality for X. All right. I'm assessing, can they solve an inequality? And I'm also assessing, can they graph it on a number line? They don't have to be the same problem. All right. So what I could say is solve the inequality. And then I'm going to throw something else completely out there. I'm going to say, graph X is greater than 3 on a number line. If I want to assess those 2 skills, let me completely separate those from each other. All right. The other piece here is if I start to separate these skills, this solving the inequality, I can ask that question and I'm assessing for procedures, right? But down here in the bottom here, after the or, I can then take that second part and assess for understanding. So a question that was originally a compound assessing for procedure question now becomes two questions. One, that is procedure, which is fine, right? But then I can also increase the DOK on the second part of that question. And we know, like kids, I do find that kids can graph inequalities, but as far as interpreting, they do struggle to interpret graphs of inequalities, whether it's linear or on a number line, whatever the case may be. They do struggle to do that. All right, so the second part of this is unpacking compound questions. All right, so let's get into this is one of my original Algebra 2, my advanced Algebra 2 tests, all right, that we're going to look at. And so please feel free to critique it all you want. I don't care. I've critiqued it with plenty of people in the past, and I'm over it. So what we're going to look at when we revamp this test, we're going to look for standards alignment. This is my Chapter 1 Advanced Algebra 2 test from 2008, I believe it was. All right, and if you've ever taught Algebra 2, you probably noticed that like the first 3 chapters of Algebra 2 are actually reviews of Algebra 1. That's maybe a discussion for a different day, but this test is not aligned to Algebra 2. It is an Algebra 1 test, all right? What else are you going to look for? You're going to look to remove any duplicates. If you've ever had a series of questions where it's like solve for X and you ask 4 questions after that, those questions become grade inflators or grade deflators when they're duplicates of each other, meaning same skill, but just different numbers. All right, if a kid can get the first one, second one, third one, and fourth one correct, their grade just went way up. All right, but if a kid can't get the first one right, they're going to get the second, third, and fourth ones wrong as well. That grade went way down. So that same skill is going to bring that kid's score way down. So removing duplicates eliminates grade inflators and deflators. And I'm not saying you can't have 2 of one type of question. I understand that, like, hey, you might want to really check, does the kid understand this? But you don't need to have 4 of the same type of question. All right. As I talked about before, we're going to look to unpack compound questions. All right. When we remove those duplicates, we got to make room for these questions that are more time consuming. The cognitive load on the kids to answer these is more demanding. So if we're going to ask questions that show their understanding, we have to remove those duplicates to make up more room on that test for just timing and pacing and things like that. All right. And our end goal here is to kind of like create a quality assessment that will drive our instruction. All right. So here we go. I laugh every time I see this because it is just, this was me teaching, getting my master's degree and coaching all at the same time. And so I would look at the lessons, the sections in the unit. I would get close to the test, like 3 days before the test, like, oh, I got to slap a test together. So I'd go to every section, pull out a couple problems, pull out a couple problems, pull out a couple problems, poof, there's my test. I would make a copy of that, just change some numbers, and poof, there's my practice test, and I was good to go. This is a direct result of that type of teaching. You'll notice here, as I show you, we're going to examine 2 pieces of this. You'll notice these where it says like in bold 3 points, 2 points. Just ignore that. When I present in front of people, we'll go through this test and kind of weigh like what weight of the test is procedure and what weight is understanding. But we're going to just kind of dissect 2 of these different sections. Yeah, we'll look to kind of revamp this a little bit. I'm gonna zoom in here, Lee. So here's the first part. Evaluate the expression for the given value of the variable. Ignore the 2 points each part. And I don't even know what was happening on number 3 there. That doesn't even fit the directions. But what I'd like you guys to do is kind of critique this, what you know so far. What types of questions are these? Are they duplicates? So just give your thoughts there in the chat window. I know, Vicky, it doesn't even have a value for X. I don't know what I was thinking. I probably just I told the kids what to do for that third problem. I don't know what I was thinking. But I wasn't going to change it for today. I wanted to keep it the original test. Yeah, these are definitely, Patty, these are definitely depth of knowledge 1 questions. I would say too that I don't remember what I did if I let kids use a calculator or not. These questions aren't difficult at all, right? Yeah, they both involve squaring. I was more assessing their ability to use a calculator. If you could plug that into a calculator, there were no problems with these first 3 problems. These would all turn into grade inflators. All right. So I'm going to give you guys a little bit of time here. How could you change these? What are you guys thinking? How could we increase the depth of knowledge on some of these questions, but kind of get at the same task here? What are you guys thinking? I agree, Cynthia. Without a doubt, this is definitely a tech test if the kids are using the calculator. So how can we change these questions? What can we do to these to increase that depth of knowledge? All right, so what I did was I made it into 2 questions. And the first one here, evaluate and simplify the expression for the given value of the variable. Oh, geez. Good. So in the first one there, you can see now that by making t equals 3, that makes the square root of 32, which isn't, if you're just going to crunch that into the calculator, I'll know that you did that. All right, so I changed up that problem a little bit here, but it is still, I would say, an assessment for procedures, which is perfectly fine. All right. For the second problem, use complete sentences to describe the error Daniel made when he evaluated the expression 3 times x squared minus 1 for x equals -2. All right, so I did an error analysis, and there's a couple things going on with this. First of all, using complete sentences, like I said, kids have to get used to writing math. Math is not about just crunching numbers. When I've seen error analysis in the past, I've seen where they'll label the lines with an A, B, C, and D. They'll label the rows and they'll say, find the row or identify the row where the mistake is made. And as a student, I remember these questions and I'm thinking, the mistake didn't happen in a row. It happened between 2 of the rows. I don't know how to explain this, but it happened between 2 of the rows. And so that's why you would have them write kind of a narrative, full sentences when they do this. Also, I didn't ask the question, is there a mistake? All right, I feel like that's kind of a trickery type question. And personally, as a teacher, I struggle to grade those sometimes because I'm not sure what is it worth if they write, no, there's no mistake versus if they write yes, but then they can't find it. So I'd like to tell them that there is a mistake in the problem and please identify what it is. It forces kids to write because some kids could just write, no, there's no mistake, and then they're done with it. All right. So don't label the rows as A, B, C, and D. Just say that there's a mistake somewhere. Describe what it is. All right. Okay. Here we go. The second part of this test we're going to look at is so this test is all about like solving equations and stuff like that. It's very common in the beginning of Algebra 2. All right. This is the absolute value section. So go ahead and take a minute, toss your feedback in there in the chat window, and let's hear what you're thinking. So I said not just testing absolute value. Barbara, if you could go a little deeper, like what else are they testing here? I'm wondering if you and I are thinking the same thing. Yep. Yep. Each set is the same problem. So yeah, we have some duplicates going on down here in the bottom and some duplicates going on up here in the top. Now yeah, there are definitely some duplicates there. There should be some positive absolute value. And yeah, Lee, you had mentioned that as well. Thanks, Melissa. So I'm going to throw this out there as well. While you guys are critiquing this, how could you make this a little bit better? How could you increase this depth of knowledge? I'm already going to say it. Let's remove some of these duplicates down here and maybe one of these up here. What kind of questions could we ask to make this a higher depth of knowledge question? Or, maybe a higher depth of knowledge for questions 8 and 9, and then a higher depth of knowledge for 10, 11, and 12. Yes, Sharon, yeah, you hit it there with the testing their fraction skills. I'm muddying the water with fractions, which, you know what, sometimes you do that, but I don't know if I need to do it twice, right? What other kinds of questions could we ask? That's good, Lee. Yep. Describe why. Yeah, don't even I like that. Like, don't say, are there any solutions or how many solutions? Just say there are no solutions to absolute value of x equals -1. Why? What would happen if we took the absolute value of 5x minus 4 instead? Oh yeah, good stuff. Yep, Melissa, the real world situations are definitely on the menu. And yeah, so I didn't ask any of those how to construct an absolute value equation. All right. So let's look at what I ended up doing here. And I went extreme on this one. I whittled this all down into just 2 questions. Please, by all means, if you want to make 2 solving equations, that's perfectly fine. But I whittled this down to just 2 questions, and this is what they are. So solve the equation. So I still have this in assessing for procedure, right? Because that's in the standards, solve absolute value equations for sure. And then I also have number 9 here. Explain why when Daniel solved the absolute value of x plus 6 equals 2x, he identified x equals -2 as an extraneous solution. So somebody before mentioned the extraneous solutions, I believe, maybe. All right, and like I said before, those don't have to be the questions you ask. It's going to be very depending on who you are, and you're going to find that when you start assessing for understanding in your tests and you change them this year, when you look at them again next year, you're like, oh, I could make this even better. I can make this even better. This whole revamping that I've been through, this whole journey of revamping my assessments takes years and years and years. All right. Yeah, Barbara, the word extraneous. We're going to talk about vocabulary towards the end as well. All right. You guys are hitting on some really good stuff here. So just keep in mind that this process of changing these questions, it won't happen overnight. It takes time. And we all know, if you've been in the game long enough, that 5 years passes really quickly. And before you know it, you're in your 14th year like I am. So just take your time, go through these and change them over slowly. But what you'll want to happen is that this eventually works its way into your instruction. All right, which is what we're going to start to get at. Yeah, right. Construct. Yeah, Chelsea wrote here, write absolute value equations that has a -8 and 18. Yeah, constructs absolute value equations. That's good stuff. So here we go. Let's move on to some assessment tips. And this includes kind of what we're talking about, but there's some other pieces I've come across as well. As far as multiple choice, I've worked with teachers on, and I am guilty of this, especially teaching AP statistics. I gave multiple choice questions all the time on my tests. The problem is with multiple choice, it's very difficult to identify what students know and don't know, or they understand and don't understand. I've often said to teachers, if you give your test, make it all multiple choice for one class and make it all open-ended or constructed response for the other class, the same questions. And you know exactly what's going to happen. The kids that take the multiple choice test are going to finish so much faster. Multiple choice questions turn into, how do I find the right answer out of the ones you've given me? Where open-ended or constructed response, questions of understanding, are more of like, how do I create this answer? How do I construct it? All right, two huge differences, finding right answers versus constructing them. There's a huge difference, all right, between those two. I would also say on the multiple choice, if you want to practice multiple choice because of a state assessment, I get it. But if it's practice, it probably belongs in the classroom and not in an assessment. There are skills to taking multiple choice tests, but have kids work on that in class, not on an assessment. All right. The second part here, avoid making your tests out of 100 points. And suppose your test has only 10 questions. All right. And now let's say the questions are worth 10 points. What's the difference between a kid that gets a 6 out of 10 on a question and a 7 out of 10 on a question? Most likely those kids have the same level of understanding. And so by making your test out of 100 points, you now have to like nickel and dime, like, oh, it's minus a half a point because your attention to precision was off. You didn't carry that negative sign all the way through. Or you forgot your units. A kid could have a full understanding of what they're doing and forget their units, and now you take off a half a point. All right. This is a tough push, especially for secondary teachers if you're not doing standards-based grading. But try holistic scoring. If you're not sure how to do it on a test, try it for your quizzes. That means just basically look at the question, and I'm going to use 5 as an example. Let's say that question's worth 5 points. If a kid gets it all right, they get a 5. If you're like, hey, you know what? You did a really good job. You had a little minor mistake here. It's a 4. And you don't have to overthink it. And then 3, 2, 1, progressive, going down. But try holistic scoring. It is much faster. It allows you to give better feedback. And it gets you out of that like nickeling, diming for little pieces and like, hey, what is this worth versus what is this worth versus what is this worth? All right. I can't recommend it any higher. Try holistic scoring. It'll change the way you operate your quizzes and your tests. All right. We talked about eliminating duplicates. All right. When you start assessing for understanding, it is a heavier cognitive load for students to tackle. You have to make room. I'll say make room on the broom for these questions and do that by eliminating duplicates. All right. Unpack compound questions. Require drawings. As a student, I wasn't a lights out math student, sorry. But I was pretty good. And I was that kid that was get me in, get me out, the path of least resistance. And if I ever had to draw something, I saw it as a weakness. If I had to draw something, it means I fully didn't understand it. And what I would suggest is I don't say force is a strong word, but require your kids to make drawings. All right. Put that in the question. So for example, show how the solution to 8 equals 2x plus 5 can be found by graphing. All right. So have them make those drawings. In word problems, and we didn't really tackle word problems because I think that's a discussion for another day, but require that written explanations reference the question. And I used to do this too. A kid would put 8 as their answer. And I'm like, 8 what? And they'd put 8 rabbits. I'm like, oh yeah, there you go. Now you're at rabbits. The kid doesn't know what they're talking about, right? They just put rabbits because they saw it in the problem. Have the kids reference the entire question from the problem in their answer. So Jimmy has 8 more rabbits than Sally. All right. And a lot of this does come from the AP Stats curriculum where the kids have to do that. So have them reference the entire question. Hopefully that'll help to eliminate the age-old question of, does your answer make sense? All right. Hopefully when they reference the entire question, they can see like, oh, you know what, that does or does not make sense. All right. And then also this last piece here is to refer to the standards of mathematical practice in your feedback to your students. So say, hey, look, I love the way you carry that negative sign all the way through here. Your attention to precision is spot on. That's great. Okay. So what's next? All right, you've created this lights out assessment that's assessing for procedures and understanding. All right, what does this look like? What are your next steps? So this is post-test creation. And some of this work comes from the work of John Almerode and John Hattie. But you want to develop success criteria for your students. So go through your test and your learning targets, your standards, and make a list of all the skills kids need to be successful in that unit. All right, they need to know how to solve absolute value equations, but also explain what they represent. They need to be able to solve inequalities and describe what the graph looks like. So you're making this checklist for students. And what this is going to do is it's going to give them an ability to self-report their grades, because from this, you're going to create formative assessments that are geared towards your standards, your tests, but also the success criteria. So as kids are taking these formative assessments or these quizzes, they're also reflecting, and make sure you give them time to do this. They're reflecting upon, you know what, for this skill, based on the feedback that I got from Mr. Kauffman, I'm pretty good. I think I have this one on lockdown, but this skill, I still need a little bit of work on. All right. And this is a big piece. I have this blue arrow coming up here. We cannot talk about student growth mindset and not provide them an opportunity to grow. All right. So you give them success criteria. You give them the formative assessment. All right. Your feedback on that assessment. And you've seen this study before where if you give just feedback on an assessment versus feedback on a grade versus just a grade, giving feedback alone shows the best results as far as growth goes. So you're going to give feedback to the students based on your formative assessments that you gave them, and you give them time in class to see that and grow. All right. I know that a lot of times we do have to give grades, but if you can find a way to hold off on that grade for a day after they've looked at their assessment, then it's totally worth it. All right. And the last piece I have here is building lessons. And I like the acronym DRAW for this. We want discourse, right? We want kids talking about mathematics. We want to hold them accountable. But I'll also say you want them, make sure you give them quiet time. Say, hey, I'm going to give you 15 seconds. There's no talking. I need you guys to wrap your head around this before we talk. All right. So D is for discourse. Make sure you get kids talking. That's how this assessing for understanding is going to work its way into your classroom. Kids need to be able to communicate mathematics, right? For reading, the 3 reads protocol is fantastic. And someone mentioned it before, but vocabulary. I know for us, a lot of the schools around me, we see the geometry scores decrease from 3rd grade on up. And I really feel like a lot of that is attributed to vocabulary. We don't spend enough time talking about vocabulary, holding ourselves accountable for it, but also holding the students accountable for that. So make word walls. Use the Frere model for vocabulary. All right. For the A, arithmetic, this is where you're going to work on fluency. If kids struggle with multiplication facts, it's not enough to say, hey, you need to go practice your multiplication facts. No 15-year-old is going to say, hey, mom, can you buy me some flashcards so I can work on this? All right, build the time into your class to work on fluency. All right. Also in arithmetic, things I like are like flow charting your math, like flow charting procedures and sequences, doing error analysis, but also you can ask students to list how a student might do a problem incorrectly. Have them do things wrong. And, so if they can do that, then that means they really understand how they could do it right. All right. For writing, I've talked about this before, but make sure they're using complete sentences. Explain their thinking and make sure they're always referencing the entire question in their answer. And for the drawing piece, we use CRA, which is concrete, representational, and abstract. Have your kids work in the concrete and representational as long as possible before you get to the abstract. All right. The abstract pieces like to multiplication, addition, whatever it is, a lot of that is the procedure piece where the understanding exists in the concrete and representational stages of learning. All right. To finish up here, when we look at what the top employers are looking for in the workplace, a lot of these pieces, problem solving, teamwork, and communication, critical thinking, creativity, they all stem from those 40-year skills, which are assessing for understanding, right? The standards for mathematical practice. It's tough to see this because a lot of times we have that weight of the standardized test kind of coming down on us, but it's totally worth working on these. And the way you do that is by assessing for understanding in your tests, and then that works its way into your formative assessments, and then it works its way back into your lessons. All right. I'm going to open it up for questions. This presentation I have here, guys, you can find on my webpage, scmath.org. And I think if you click and pop it out, you can go to the editor, and you can actually even get a link to that Algebra 2 test if you want to turn this around in your own department or whatever that looks like. Feel free to reach out to me. My email address is dan@scmath.org, and my Twitter handle is KAUDAN721. But I'll open up this up to questions or just general discussion.
So Dan, thank you very much. I gathered some questions in the chat window while you were presenting.
Okay.
One question was, how has assessing for understanding like this changed the way you teach kids?
So you have to give them time. Sometimes you work with kids that are like, even your struggling groups, like, I don't think I could do this. I don't think I could use, I'm going to reference vertical non-permanent surfaces. I don't know if I could have kids standing up and talking about it. A lot of times that's exactly what those kids need, especially the kids that are in like remediation groups. They've been given the same math over and over again, but it kind of holds them accountable for knowing it. If I have to communicate what this looks like on a test, I have to be able to communicate what it looks like to somebody else. And so it opens up your classroom to this whole communication piece. Like, how are kids talking about this? I have to make time for it to practice if I'm going to value it on my assessment.
Oh, that definitely makes sense.
Yeah, and I'll say, and I keep going back to this, but I've started using Convince Me That a lot, and I use it in elementary grades, and it is amazing. Just tell your kids, hey, convince me that such and such and such is true, right? You limit them to one marker and one whiteboard in groups of 2 or 3, and the focus, you've already given them the answer, right? So convince me that 3 + 5 is 8. Their focus now is on the how am I going to draw that? How am I going to do this? And it puts the stress is taken off of finding the answer, and it's put on how do I communicate that. So I love the verbiage of convince me that.
Yeah, that is true. And I think having them like work with one marker for the whole group is also good. I don't know. I think it actually forces them to work together. There was another question. So if in terms of standards, like, do you have any documents that students might have to keep track of the standards for themselves or the learning objectives for themselves so they can kind of track their own progress?
Yes, I do. And it's a bare bones document, but in one column I'll kind of describe it because it's easily replicable. In one column, I'll have like the I can statement, like at the top, and then I'll have a two column table where I'll have like the skills on the left, like I can solve an absolute value equation, and then I'll have a place on the right hand side for them to assess themselves. And then below that, I'll have I can graph an absolute value equation, and then on the right, I'll have a place where they can, write how they're doing or, self-report their grade, their progress in that skill. So it's just a bunch of tables, and I have one. I don't know how I'll get it to you, but
there is a place up here on the top above the chat window to put handouts, and if I can get one of those from you at the end of this, I can put it there, and then people will be able to see that in the downloads when they come back to look at the recording.
Okay.
Or we can put it up there, right at the end here, so the people that are here can even grab it if they want. Let's see. There was another question about holistic scoring. Let's see. It says if students do some work but not all, but it's not all correct, are they still getting a 1 or do you get a 0? Like, who gets a 0? That type of thing. Does anybody get a 0?
So that's tricky. So a lot of the holistic scoring I see is we use Eureka Math or Engage New York in our elementary, and those are scored 0 to 4. And the way that I typically tell teachers to score them is 4 is you've gone deeper than the grade level is asking you to go, or deeper than the standard is asking you to go. A 3 is you know what you're doing, but you might have made a minor mistake. A 2 is that, you know what, I think with a little bit of help, you can get where you need to get go. With a little bit of help, you can get where you need to be. That's what a 2 is. Maybe come and see me, and it's okay. A 1 is, oh my gosh, we need to back up the bus here and figure this out. The problem with scoring like that, and you might already be thinking about that, is scoring on a 4, 3, 2, 1 is not quantitative, it's qualitative. So teachers will try to say like, oh, if you got a 3 out of 4, that's a 75%. But it's not. A 3 might be an 85%. So you have like this mapping you have to figure out. And that's why I kind of picked a 5, because then a 4 out of 5 is like an 80. Maybe a 6 is a better number. But yeah, you kind of put kids into categories, not giving them numbers, if that makes sense.
Yeah, no, that makes perfect sense. Do you, I guess one of the things I see myself is sometimes kids will try to argue over points type of thing.
Yeah. Oh, yeah.
So, well, not with this so much, but like I could see how they wouldn't argue over points with something like the holistic scoring. Do you think that's true?
I would agree, because you're not taking little points off. You're not nickel and diming and putting tick marks. We're all in the same category. Hey, we kind of understand what's going on. We're all proficient. Is maybe a better word to use there. Maybe that is a better word, but yeah, you're right. The nickel and diming is not there. And also as a teacher, it's actually faster to grade if you do it holistically, because you're kind of just taking a glimpse at the entire problem, not trying to read out all the fine print in there and trying to get into the kid's head and stuff like that.
Yeah, that makes sense. Are there any other questions for Daniel at the moment? So I would like to thank Daniel for presenting. Thank you very much for sharing this with us tonight and making us think about becoming better at assessing our own students' understanding and how that might impact how we actually teach. Originally, we did not have a presenter scheduled for next week, but we actually do have a presenter now scheduled for next week. The session is called Women Who Count, Honoring African American Women Mathematicians, and it's being presented by Shelley Jones, who is a professor at Central Connecticut State University, and she is going to be talking about a book she's written, and she's going to be sharing some information about some of the 29 featured mathematicians that are in the book that she's created that's designed for elementary and middle school students. But I think it's actually a fascinating topic for anyone who teaches mathematics. So I hope you will be able to join us next week for that presentation. If you have any other questions for Dan, please feel free to email him, or you can even post them right now in the chat room window before we all sign off for the night. So thank you very much, Dan.
All right. Thank you, guys. Yeah, thank you, Lee, for hosting.
Yeah, no problem. Glad to do this.